Good day, everyone. We are Group 4. I am Erin Cibulo.
Mayan Basilia.
I am Nesto Peña Francia.
Ethan Rafalio.
River Paul Rimas.
I'm Robangalovi Tandingan.
And today we will be discussing the aircraft fire detection and warning systems. This topic is especially critical in aviation because, unlike on the ground, a fire in flight leaves very limited time to respond. That's why aircraft are designed with systems that can detect, warn, and help control fires as early as possible. Next. To understand fire detection systems, we first need to understand how fire actually starts. Fire is the result of a chemical reaction called combustion, and for this to happen, three elements must be present: the heat, fuel, and oxygen, which is what we call the fire triangle. If we remove any one of these, the fire can be controlled or extinguished. In aviation, these elements are almost always present. For example, fuel systems provide flammable liquids, electrical systems can generate heat, and oxygen is naturally available in the air. Fires are also classified into different types. Class A involves solid materials like cabin furnishings. Class B involves flammable liquids such as jet fuel. Class C involves energized electrical equipment, and Class D involves combustible metals, which are common in engine components. And lastly, Class K involves cooking oils, which are most commonly seen in galleys. This classification matters because not all fires are extinguished the same way. Using the wrong method can actually make the situation worse. That's why early detection is very important since it allows the crew to respond correctly before the fire escalates. The main goal of fire detection system is early detection. The earlier a fire is detected, the higher the chances of controlling it before it becomes critical. It's also important to understand the difference between detection and indication. Detection happens at the sensor level. This is where the system identifies abnormal conditions like heat or smoke, while indication, on the other hand, is what the pilots see or hear in the cockpit, such as warning lights or alarms. In simple terms, detection is the sensing, while indication is the communication. There are several detection methods used in an aircraft. First is the heat detection, which is common in engines, smoke detection, which is used in cargo and cabin areas, flame detection, used in high risk zones, and some systems also detect gases or particles, although those are very less common. The choice of method depends on the specific area of the aircraft and the type of fire risk present. Now we will be discussing the different types of detection systems, starting with the thermal detection. Thermal detection systems are one of the most widely used methods, especially in engine and APU compartments, where high temperatures are expected. Continuous loop systems, like KIDE and Fenwal, provide constant monitoring along a sensing loop. The KIDE system works by detecting pressure changes caused by heat, while the Fenwal system detects changes in electrical resistance. What makes these systems effective is their ability to monitor large areas continuously rather than just a single point. There are also spot type detectors like thermoswitches and thermocouples. Thermoswitches activate at a specific temperature, while thermocouples respond to a rapid temperature increase. These are often used in critical locations where immediate detection is necessary. Overall, thermal systems are valued for their reliability and quick response. Moving on to smoke detectors. Smoke detection is particularly important in areas like cargo compartments and cabins, where a fire may start unnoticed. Different types of smoke detectors are designed for different fire behaviors. Optical detectors are better for slow, smoldering fires, such as burning insulation or fabric. Ionization detectors are more sensitive to fast, flaming fires, but can sometimes trigger fire alarms. while aspirating systems take detection a step further by continuously sampling air, allowing them to detect even very small amounts of smoke at an early stage. Modern aircraft often use multi sensor detectors, which combine multiple technologies. This helps improve accuracy and reduces false alarms, which is very important in aviation, where unnecessary warnings can disrupt operations. Next is the flame detection systems, which are used in high risk areas where fires can develop very quickly, such as the engines. These systems detect radiation emitted by flames. Ultraviolet detectors respond very quickly but can sometimes be affected by external sources like the sunlight, while infrared detectors are more stable but slightly slower than ultraviolet detectors. To improve reliability, many modern aircraft use combined UV and IR detectors. These systems balance speed and accuracy, reducing the chances of false alarms while still providing rapid detection. Flame detection is very crucial in some cases, especially in fuel rich environments where a fire can escalate within seconds. Now, once a fire is detected, it must be controlled or extinguished, and one method to do that is the water based fire extinguishing system. These systems work primarily by cooling the fire, by the water absorbing the heat, then lowering the temperature and slowing down the combustion process. In some cases, it also produces steam, which helps reduce oxygen around the fire. There are different types, such as sprinkler systems, the water mist system, and the luge system. Water mist systems are especially effective because they use fine droplets, which improve cooling efficiency while minimizing the damage to equipment. In aviation, these systems are more commonly used in ground facilities like hangars, but some aircraft also use water mist systems in cargo compartments. They are widely used because they are cost effective, easy to maintain, and very effective for certain types of fires.
Gaseous fire suppression system. Uh, gaseous fire suppression system used to rapidly extinguish flames, prevent reignition, minimize damage to aircraft system, and ensure the safety of the crew and aircraft. Gaseous fire protection system uses special dry chemical to prevent more damage to the aircraft and the entire crew. Example is Halon 1301, Halon replacement clean agents, inert gas suppression systems, and advantage for this gaseous fire suppression system is rapid fire extinguishing, residue-free operation, safe for environment, unsensitive equipment, effectiveness in enclosed system. Dry chemical suppression system. Dry chemical system use powder agents to quickly stop fire by interrupting the chemical reaction. They are effective on fuel and oil fire, but may leave residue. It is not suitable for delicate systems because they leave residue. Monoammonium phosphate, sodium bicarbonate, and potassium bicarbonate. For advantage of this dry chemical, it is very fast knockdown, effective on fuel fires, non-conductive and simple and reliable. Uses in aviation, aircraft hangars, fuel servicing area, maintenance shops, and ground fire extinguishers. Engine fire protection system. Engine fire system detects and extinguishes fire using heat sensors and extinguishing agents like halon. They are critical for turbine engine safety. The main purpose for this fire protection system is to isolate the engine compartment, alert the flight crew, and from fuel and other sources. Detectors used in this engine fire protection system is continuous loop, such as halon fire extinguishing system. The main purpose of this cargo fire system is to protect the cargo of the aircraft. Extinguish fire in the aircraft's cargo compartment to protect passengers, crews, and the aircraft itself. There are four different types of detector used in this compartment. Smoke detectors, photoelectric detectors, ionization detectors, and heat detectors. Cargo compartments use smoke detectors and automatic extinguishing system, usually gaseous agent to control the fire without crew access.
Warning indication and pilot's response. Warning indication lights alert pilots to abnormal or emergency condition, such as an engine fire. Red lights indicate a serious problem requiring immediate action, while amber lights indicate caution. These warnings are often supported by alarms. When a warning appears, the pilot must act quickly, identify the problem, follow emergency procedure, shut down the affected system if needed, and activate fire extinguishing systems. Proper and immediate response is critical to ensure flight safety. Next. Types of fire extinguishers. There are several types of fire extinguishers used in an aircraft. First, Halon 1211 or Halotron. These are clean agents that interrupt the chemical reaction of fire. They are highly effective and leave no residue, making them ideal for sensitive aircraft components. Second, carbon dioxide or CO2. This works by displacing oxygen, effectively suffocating the fire. It is commonly used for electrical fire but must be used carefully in enclosed space. Third, dry chemical extinguisher. This use powder to smother the fire and stop the chemical reaction. They are effective on multiple fire types but can leave residue that may damage aircraft systems. Each type is selected based on the type of fire and location in the aircraft. Next. Engine fire warning panel. The engine fire warning panel is located in the cockpit and provides pilot with immediate information about fire condition in the engine. It typically includes fire warning lights, switches, and fire extinguisher discharge control. When a fire is detected, the panel will illuminate a warning light and may trigger an alarm. The pilot can then activate fire suppression system directly from this panel. This centralized system allows for quick and efficient response during emergencies. Next. Types of fire warning indication. There are different types of fire warning indication used in an aircraft. First, visual indications, such as flashing red lights or illuminated warning panels. Second, aural indication, including alarms, bells, or voice warning that alerts the pilot without even looking at the panel. Third, sensor-based system, such as heat detectors, smoke detectors, and flame detectors, which automatically trigger warnings when fire conditions are detected. These systems work together to provide early detection and immediate alert, giving pilots enough time to respond effectively. And that's all for our reporting. I'm River Palorimas together with Erin Cibulo, Rob Tandingan, Ethan Rafalio, Nesto Peña Francia, and Maihan Basilia. Thank you.